This is the homework helper for Chapter 5, Section 7 in the 8th grade textbook entitled Indirect Measurement. All right, let's go ahead and start off with number 1. It says, Tamara wants to know the width of the pond at the park. She drew the diagram and labeled it with the measurements she made. How wide is the pond? So obviously what we have here are two similar triangles. Now what might be tricky is the way they are drawn, they're kind of drawn inverted. Usually when we draw similar shapes, as you heard in the notes, we want to orient them in the exact same direction. And these are not oriented in the same direction. Because as you can see, what's most easily identifiable is these right angles. In this triangle, the big one here at the top, the right angle is at the bottom. But in this smaller similar triangle, the right angle is at the top. So if you need to redraw this bottom triangle so it's drawn the same way as the big guy up top, well, if I redraw this guy, that means that side that measures 15 is going to be up at the top, and the side that measures 9 is going to be at the side. All right, now remember, in these shapes, what you want to do is set them equal in the exact same way. So we're going to compare the top and the left and the top and the left here. And I forgot my right angle mark. We'll draw that in, but not a big deal. So I want to put fraction bars in that compare top and the left and the top and the left. So we're going to say question mark over 36 is the same as 15 over 9. Now, maybe you're saying, I don't want to do it that way. Maybe I want to compare the left and the top in the other direction. That's fine. All right, put your fraction bar so it does 36 over question mark and 9 over 15. And then compare them. Again, what's important is the order you compare them. When I pick question mark over 36, I'm saying top versus left side. So when I come over to this guy, I write the fraction the same way, top over left side. All right, so we've got our proportion, question mark over 36 equals 15 over 9. Now you want to solve by cross multiplying. So on the diagonal with 36 and 15, 36 and 15, when I multiply those together, makes 540. So the other diagonal also has to make 540. So I'm saying, what number do I multiply by 9 to get to 540? Well, when I do that, the result is 60. So the pond must be 60 yards wide. Now, if you want an easier approach, at least as far as the work goes, we can come back over here and say, well, 9 and 36, I know the relationship between 9 and 36. To go from 9 to 36, we'd be multiplying by 4. True statement. So you're going to do the exact same thing on the top because that's the only way this works. So I'm going to take that 15 and then multiply it by 4, and the result is, again, no surprise, 60. All right, let's go ahead and take a look at number 2 and number 3. It's asking me to use the diagram that's drawn there. And as you can see, my diagram is 3 similar triangles there with a flagpole and a person, that's the small one, and then a really big tree. And they want to know in number 2 how tall is the flagpole, and in number 3 how tall is the child. All right. So let's start with realizing what we have here. This illustration out here with the tree is the only one in which we have the two pertinent sides. We have the shadow and the actual tree. This one we're missing the height of the person in this one. This one we're missing the height, in this case, of the flagpole. So I'm going to have to make a comparison to this one for the flagpole in 2, and from this one to the, again, the tree in number 3. Flagpole to tree in 2, person to tree in 3. Now, again, if you're missing out why this is similar figures, you can draw the sun's ray in as the third side, and there would be your triangles. I'm going to go ahead and take those out because it's cluttering up my drawings a little bit here, but that's how you were talking about similar figures here. All right, so again, since both of these are compared to the tree part, all right, we're going to make this into a fraction. Let's compare the height to the shadow. So the height to the shadow here is 51 over 119. And again, that's just me making a decision in life. If you want to compare it the other way and compare instead the shadow to the height, that's fine. Remember, though, you have to stick with that comparison the whole way through. So when I come over here to the flagpole, I want to make the same comparison, the height to the shadow. Well, insert my fraction bar the same way. Well, we don't know the height, so that's where your variable is going to go, x. And the shadow here is 84. All right, now most of us don't know how to go from 84 to 119 or 119 to 84 right off the top of our heads. So at this point, we want to go ahead and solve this one by cross multiplying. So that one diagonal says 51 times 84. 51 times 84 is 4284. Remember, the other diagonal has to be exactly the same, 4284. So I'm saying to myself, what number am I going to multiply by 119 to get to 4284? Well, when I take 4284 and divide by 119, the result is 36. So the flagpole has to be 36 feet tall. Same tree comparison here for number 3, height to the shadow, so 51 over 119. But when I write my other fraction here, it's going to be the comparison of the height of the child, which we don't know, so that's going to be our variable x, to the shadow 7. Now 119 to 7 might be one you recognize, maybe, maybe not. To go from 119 to 7, you're dividing by 17 here. So the same division is going to have to work in the numerators here. So if I take 51 and divide it by 17, the result there is going to be 3. So the child is 3 feet tall. Now, if you want to solve this with cross products, you can. What you would do is you'd start off and do 51 times 7 there. 51 times 7 on that diagonal is 357. Well, the other diagonal, that means also has to make 357. So I'm saying, what number would I multiply by 119 to get to 357? Well, 119 times 3 is 357, which is no surprise since our answer was 3. So the child is 3 feet tall. All right, we'll conclude by looking at number 7. It says a warehouse is 120 feet tall, cast a shadow that's 288 feet long. At the same time, Julie casts a shadow that is 12 feet long. How tall is Julie? So a little drawing would be nice here. We've got a building that's 120 feet tall, and it's making a 288 foot long shadow. Then you've got Julie. Julie cast a shadow that is 12 feet long. And we're supposed to figure out how tall Julie is. Well, remember, the sun's rays make up the third side, and that's how we get our similar triangles here, our similar shapes. So we want to make a comparison here given the triangle we know everything about, the one on the left. We can compare the height to the shadow, or we can compare the shadow to the height. It doesn't matter, we just have to pick one. I'm going to compare the height to the shadow. So 120 over 288. So I'm going to make the same comparison over here, Julie versus her shadow. Well, we don't know how tall Julie is, but we know her shadow is 12. So this height is going to be x. So our proportion here is 120 over 288 equals x over 12. All right, now at this point, I want to go ahead and solve, and I want to either cross multiply or figure out what the multiplier or divisor is I'm using there, in this case, in the denominator where I have all the numbers. Well, to go from 288 to 12 in the denominator, you're dividing by 24. So the exact same thing has to work in the numerator here, dividing by 24. When I take 120 and divide by 24, the result is 5, as in 5 feet. So Julie must be 5 feet tall. If you want to solve the other way with cross products, you're going to do 120 times 12 which is 1440. And then you're going to say to yourself, what number would I multiply by 288 to get to 1440? Well, if you take 1440 and divide out the 288, the result is still 5. So either way, either approach to solving doesn't change Julie's height. Julie is 5 feet tall.